Tutor, where school is made simple. Let's go.
By definition, a parabola is a set of points equidistant from a given line known as the directrix and a fixed point known as the focus. We have selected a point on the directrix that we will use to be our random point. Then we're going to connect this point on the directrix with the focus, and this will eventually form the base of a triangle. The other vertex of the triangle is going to be a random point that we call point E, and we're going to test this point to determine whether or not it satisfies the definition of a parabola. So we will measure the lengths of the two legs of the triangle, and we see that they are not congruent. They are not equal. We can randomly move the point around, but that will not give us any better results. In theory, we can select a point, measure the distance from the point to the directrix and focus, and determine whether this is part of a parabola. In practice, however, it is nearly impossible to find a randomly selected point which is on the parabola. As we see in our current example, the distances between point E and the focus in the directrix are not equal. Simply moving the point around will not help us find equal distances. This is why geometric construction is the only way to properly create a parabola from a directrix and focus. We can, however, use something known as the isosceles triangle theorem, which states that the perpendicular bisector of the base will pass through the vertex of the isosceles triangle and also bisect it. Additionally, we know that the shortest distance between a point and a line is a perpendicular line through the original and through the given point. So if we construct a perpendicular line through point F and perpendicular to the directrix, where it intersects with the perpendicular bisector of the base should be the point on our parabola. When we construct this perpendicular line, we see that it is not our randomly chosen point E. We will place a point at the intersection of the two perpendicular bisectors, and we will remove the original triangle. Now we will construct the segments between this new point and the directrix, and this point and the focus, and then we will measure their lengths to confirm whether or not this point satisfies the definition of a parabola. Now we will hide this perpendicular line and create a line segment in its place. And finally, we will measure these two. Now we can clearly see that on our first attempt here, these two segments match. Now, as we move around our point on the directrix, we can see that the corresponding intersection point between the two perpendicular lines will move, but the distances will remain constant, the distance of the two legs, the distance from the focus to point G and the distance from the directrix to point G. Now, as we animate point F and trace the intersection point G, we clearly begin to see the shape of a parabola forming. And this is the geometric definition of a parabola, which is a set of points equidistant from a line and a given point. This is the difference between the algebraic graphing and the geometric graphing. However, the shape is the same, and we can find a corresponding algebraic expression for this.